A confirmation about the audio, please, guys, for the final time. Clear? Okay. Do we have some energy left, or is the all the energy gone by the entirety of the weekend? I understand that the weekend sessions are particularly heavy for many of you, and it takes a heavy toll on many of you. I understand that. But then energy is there. Good to know. No, in the case of mapping, I would rather, Akshay, I would give you certain areas which I would want you to map it out on your own over the duration of the week, over the entire portion of the week. You will have those days with you. You can map out those various areas. I'll give you a lot of places to map out, and that will be in a way also allowing you to cover the rest of the world in terms of the geographical and the geomorphological reaches for the rest of the world. Okay, so always I maintain, guys, that for those of you for the weekend session, that think about it as a practice for your mains examination, because mains examination is when you will be asked to have a much larger toll on your body, on your in a physical state, mental state as well. Because in the morning you are supposed to write a particular set of answers, in the evening also you are supposed to write a set of answers. So think about the weekend sessions as a kind of a training ground for all of that. Okay. Now, anyways, coming to the final topic, and that is the landforms developed by the wave action, the landform that is created by the sea wave. Now the sea wave, also that water is salty, right? Sea wave, it is the saline water. Now that saline water has got the property to carry out chemical erosion as well, chemical weathering in the sense of erosion. And also simultaneously, that particular sea water, by the physical force, also ends up attacking the coastal areas and the coastal landforms, that is the rock surfaces, etc. That is why the various different landforms that you see in existence in the coastal areas, many of them, they are a byproduct, or where you have twin actions acting. That is the chemical action by the salty seawater and the physical action taken by the force of the sea waves. Okay, so in majority of the landforms developed by the waves, you will observe both of these actions at play. That is here chemical action by the salty or the saline seawater, and then physical force exerted by the waves. Okay, so both of them are in action. So these sea waves, they also create depositional features such as sea beaches. The sea beaches that you observe, they are nothing but depositional landforms, where you will find that basically as the sea waves come in and go back in a region, they end up depositing certain materials that they bring about from the portions closer to the sea itself. They will bring about those materials, they will keep on depositing them, and that is how in many of the areas large sea beaches, they are created. In most of the cases, you will find that older the sea beach, finer is the size of the particles. The particle size is very, very small, right? And where the sea beach has been created in a very recent period of time, in very recent past, you'll find larger particles in existence or coarse particles in presence. So you have various erosional and depositional features created by the action of the sea waves. Let us take a detailed look at each one of them. One of the most massive and as well as visually stunning landforms, which is erosional in nature, that is the sea cliff. Cliff basically refers to any of those landforms where you have a kind of a sudden incline, a kind of a steep slope which is present. That is always going to be a characteristic feature of a cliff, where you will find that there is quite a significant drop, sharp drop, which is present. Now, how are these sea cliffs created? Again, in many areas, you have a combination of both physical as well as chemical action. But let us consider the case of mostly the physical action being dominant. So, here, at one point of time in history, this region would have been somewhat like this. Okay. And the seawater would have come here. Now, as the sea waves would attack the base of these rocks, so the base of the rocks, basically due to the physical force, and also think about it that the salty seawater would be able to react with the minerals in the rocks. Many of those minerals would be dissolved as well. So they start getting weaker and weaker before the rocks eventually break. Right? So that continued presence or the continued action of the sea waves, it creates a kind of a situation, a kind of a landform, which can be thought about to be somewhat like this, where the base has been eroded. Okay. And the seawater then comes up till here. Right. Now, here you will find a kind of a protruded portion. Protruded in the sense which is overhanging. That is the protruded portion. So, that protruded portion is what is referred to as a notch. That is what we regard as a notch. Okay. Now, here, over a period of time, you can think about it. Now, let's use a fresher image for this. A notch which is overhanging, right? And then you have the presence of water underneath it. Now, here, think about it. This protruded portion, will that be strong structurally? The physical strength of it, will that be strong enough? Obviously not, because it is overhanging. There is no support to that. Plus, to add on to the fact, it will be exposed to heating by the sun, rainfall, and also chemical weathering. So, over a period of time, you would observe that this region starts weakening. I hope you are able to visualize this, that this overhanging portion that starts to weaken in its structure. Now, when it weakens, it will break off, it will fall off. And when it falls off, you have a structure which is created, which is somewhat like this. Right? Where the top portion has simply broken off. Okay? The top portion has simply broken off. Now, already you can see there's a kind of a wall-like formation here. This process will further continue. And when we say this process will further continue, in the sense that this sea wave will again continue to attack the base. And when the base is attacked, there will be an inundation, a kind of a indenture formed at the base as well. So here you will observe a kind of a feature again, somewhat like this. Right? And here you will find that the seawater would have penetrated further here. Right? Again, this overhanging portion forms a kind of a notch, which again will be very unstable. It won't be strong structurally and physically. So again, this notch will be weaker. This notch this time will be blunt, a bit blunt as well, but it will be weaker. Okay. But then again, the same process will repeat in the sense that this notch will be exposed to weathering events, etc. And then again, this might break off and this will weather. So, like that, a continuous repetition of the process will lead to creation of a wall-like feature closer to the sea. A wall-like feature closer to the sea. And that is what we refer to as a sea cliff. So sea cliff is created due to multiple different stages of wave erosion which is carried out. First of all, it will attack the base, and then the top portion will tumble gradually as it becomes weaker. Again, it will tend to attack the base. Again, the top portion will start to tumble, it will get weaker, and that is the process which is repeated. So that is the case of the sea cliff. In India, where do you find the presence of sea cliffs? In Kerala. You would have heard about the name Varkala. So Varkala in Kerala is quite renowned for the presence of sea cliffs. The image that you see is that of the Scottish Highlands. Right there also you will have, basically these are limestone rocks. So there you have chemical dissolution by the water also, which is carried out simultaneously, and that creates these sea waves. Now observe, now all the materials which would have broken off, which would have entered into the sea, many of those materials basically would have been slowly and steadily brought by the sea wave, and they would have been deposited here. So that would lead to creation of the beaches, right? So observe here, you don't find the presence of a beach as of now, but it might be possible that over many years the materials which have been put into the water, those materials are accumulated by the sea action, and those materials, they start accumulating here, forming a kind of a beach like creation. So that is how you have the action by the sea waves. Now, these sea waves, they bring certain materials, and the materials get deposited closer to the coastline because that is where the speed of the water is very slow. And again, we will apply the same basic principle that carrying capacity is directly proportional to the factor of speed. So, if whenever the speed of water becomes slower, that is when deposits will happen quite significantly. So here let us take a look at certain other characteristic of deposits, certain other kind of deposits which are carried by the sea wave. First of all, here you observe that in certain cases, what happens is that as the water comes in, goes back, comes in, goes back, it ends up depositing certain materials which are parallel to the coastline. It will end up depositing certain materials which are very parallel to the coastline. Obviously, in a shallower area, closer to the coastline, it will deposit such materials. You'll find a lot of such kind of deposits in the coastline around Kerala. There you will find a lot of such deposits. Now, these deposits that you see, which are parallel to the coastline, they are referred to as bars. Okay? Deposits parallel. Yes, Parshuram, this is the top view. Parallel to the coastline. This is what is referred to as bars. Okay? Then, sometimes the deposits happen very much attached to the coastal area. So let's suppose now all the coastline is not going to be straight. Somewhere you will find that the coastline has got a kind of an indented shape, somewhat like this, isn't it? Coastline will rarely be very straight. It will always have a kind of an indenture, somewhat like this. If this is the land area, if this is the sea, right? So sometimes the deposits, they will be initiated in these portions, in these areas. But then, if ever you have visited a coastal area, you would have experienced that the wind movement, the wind velocity is very high in the coastal areas, right? The wind velocity and the wind movement is very, very high because obviously in the coastal area, the wind experiences very little amount of resistance. So that is why the velocity is very high. Now, when you have a kind of a horizontal wind which is moving parallel to the coastline, horizontal wind which is moving parallel to the coastline. Now, the deposits also will be shaped in that direction of the wind because the wind will influence the direction of the deposits. So, that is when the deposits, when they are attached to the coastline, they are carried away in such a way which is parallel to the coastline influenced by the wind. Those deposits, they are referred to as spits. These are referred to as spits. So spits in simple term is the deposit attached at the coastal area influenced by the horizontal movement of the wind where the deposit shape is parallel to the coastline. So here you might have the question that bar was also parallel to the coastline, but bars are not attached to the coastline, right? Bars are independent of the coastline. Spits are attached to the coastline always. So that is the case of spits. So here, influenced by the wind movement. So it is basically attached to the coastline. Okay. Now, here, many of the times you would have seen that if this is a coastal area, let's suppose this is your land, this is your sea. Now you will find small island-like formations closer to the coastline, right? Small island-like formations. Spit won't break, attach millions together. Kavana, what is the meaning of the question that spit won't break, attach millions together? Please let me know. So here you will find that many of the times you have few islands very closer to the coastline. Now in this area, in this particular region, if I hope you are able to see the pointed portions. In this particular area, if I ask you the question, the speed of the sea wave, will that be fast or will that be slow? The speed of the sea wave in general in this area, will it be fast or will it be slow? Obviously, correct? It will be very, very slow in this area. So whenever the speed is very slow, deposits will happen. So many of the times the deposits, they will end up joining the mainland with these tide islands. It will join the mainland with these islands by the depositional feature, right? And these are your deposits. These deposits which join that island with the mainland, they are referred to as by the name tombolos. And the island, which is no longer an island, because for an island you need the land to be surrounded by water from all sides, that is no longer an island. So this will be referred to as a tide island now. It has been tied to the mainland, and this is what is referred to as a tombolo. Okay, that is what you have as tombolo and spits. Difference between bar and a spit, as you can see, this is a spit, this is a bar. So bar is not attached with the coastal area. Okay, bar is not attached to the coastal area and bar is independent of sorts. Whereas the spits are attached to the coastal area and bars are not influenced by this wind movement parallel to the coastline. Whereas the spits are and the deposits are influenced by the coastline and the wind movement. If you take a look at these spits, sometimes these spits can extend for tens of kilometers altogether. Observe this. This is a kind of an example of a spit formation. So this is attached to the coastal line. And observe how long it stretches into the water. Right? So this is your example of a spit. Whereas here, when we talk about this was at one point of time a kind of an island. Now the deposits have joined it with the mainland. So this will be regarded as what? That is what we have as a tombolo. Okay, so tombolos, they join a particular island region to the mainland, and that is what is a tombolo. So then the island becomes tide island. This becomes a kind of a tide island. Okay, Priya, these bars doesn't push by the sea currents towards the land. See, the bar deposit, it is not going to see when you picturize or visualize a bar. Let me give you a cross sectional analysis also so that you are able to visualize it. So if suppose this is the land area, this is the water body, right? When you talk about a kind of a bar, so bar will be created in the deposit somewhat like this. If materials will get deposited here, this will be the cross-sectional view of a bar. Okay, so this is still very much fixed to the land underneath. So this bar that you see, it will be fixed to the land underneath. It is not going to freely float over water, that today the bar is there, tomorrow the bar has moved 50 kilometers away. That is not the case. It is very much attached to the base here, right? So for example, around Trivandrum, around Kovalam, ever if you happen to go, you will observe many of these bars. Eventually these bars, they end up getting joined to the land also, and form many backwaters also in the region of Kerala. Okay, and submerges to space. I hope, Priya, that is understood. Tombolo will be visible outside and submerged with water. No, this is Tombolo is always visible outside, and yes, it will be submerged in the case of water to a particular depth. What deposit will be there? I mean, shell marine deposit. Where? In these cases of spits, it will be sand. It will be the sand particles which will get deposited, the sand particles which are brought by the sea waves from these coastal areas. It is those sand particles which will be deposited. Is that understood? Tombolo seems like a strait. No. Strait, in fact, is the water body which combines two larger water bodies. That is a strait. Okay. Is Ram Setu an example of it? I'm not going to go into the detail of Ram Setu. But spits not attached with coastal area. Where do you see the spits are not attached? In this case, they are attached to the coastal area here. Spits will always be attached to the coastal area. Otherwise, it will be a bar. Okay, Ganesh. And how these can be asked in the mains, as I told you earlier also, in mains, you can have a question that, for example, this year you had a direct question in the mains, which was asked about, what do you understand by fjords? Right? Where are they found? So that was a direct question which was asked this year. So it is a direct question from the portion that we have discussed. So either you can have that kind of a direct question, or you can have a question analysis based question that discuss the kind of landforms or the kind of erosional landforms created by the wind action, discuss the kind of depositional landforms created by glacial action. Right? Yes, Parshuram. Yes, Himanshu, that is correct. And some stones will float on sea. Does it similar? No. If you have few stones which are floating in the sea, bars basically they will have their depth fixed to the this region. That is what you associate with the case of bars in general. Okay. Now, Dhanush Kodi is an example. Dhanush Kodi that you see, that is very much an example of a bar to some extent and spit to some extent. Satish, is spits and tambolos considered as sediments or the result of decrease? No, they are mostly a result of these sedimentary deposits. Spits are attached, Benjita. Okay, is that understood? Now, then here you have a series of these. So basically, series of the erosional landforms. So here basically you will observe this in a kind of a chronology. So many of the times what happens is that, as we have already talked about, that in the seawater, in the marine area, you will have chemical action of the water which is prevalent. Now that chemical and physical action is able to dissolve the rocks in many of the cases, break the rocks in the many of the cases, and create coastal caves, right? Coastal cave-like structures are created. So seawater will enter these coastal caves. Sometimes they will exit from the other side as well, right? But these caves, they get created in the coastline. In the Italian coastline, for example, in the French coastline, you will find many such features, Spanish coastline, etc. You'll find many such features. Now, if let's suppose water manages to enter and exit, so there, in the sense that the cave becomes continuous, you are basically looking at a kind of an arch-like structure where water can move from one side to the other with a kind of an overhanging roof. But if you think about it, will that roof be stable? Because that roof will be exposed to huge amount of rainfall as well. That roof will be exposed to the vagaries of nature as well. So will that roof be stable? Obviously not. That roof can collapse. When that roof will collapse, and it is not about if it will collapse, it will definitely collapse, it is about when it will collapse. So when that roof collapses, you are left with a kind of an isolated, this particular platform will be left isolated, and that is what you refer to as a stack. So a stack will be left over. Okay, you will have a kind of a stack which is left over. Now, even this will undergo weathering, sea spray, etc., and their size will be further reduced. It will be a kind of a stump. So, like that, in many of the coastal areas, the land is continuously consumed due to erosion, and the water comes inwards towards the land. And in the process, it creates all these kind of landforms in the process. Okay. Now, the kind of prelims questions which can be framed from this. So, cirques, arrets, this is a very simple question. I'll not give you more than 15 seconds for this. Cirques, arrets, horns, and drumlins represent which kind of topography? I think even 15 seconds is much more. Yes, correct. Very good. Still, I have at least 16 people who have managed to give the incorrect response. So, kudos to you guys. I don't know why you have managed to give incorrect response in this. But cirques, arrets, horns, and drumlins, they are the glacial landforms, right? Created due to the glacial action. So the correct answer is going to be C. This is a question that we have already discussed, right? We have discussed this particular question. I don't think anybody is going to have any doubts in that. Yeah. And then we come across, okay, mistakenly typed, then it is fine. See, it was 15 seconds. In examination, you will get more time to attempt these questions. So you will be in safe hands. Don't worry. Explain the formation of thousands of islands in Indonesian and Philippine archipelago. Now, these islands are created why and how? That is because of oceanic convergence, right? So in this answer, you have to explain about the process of oceanic convergence. You have to name the oceanic plates. That is the Indonesian plate on one, that is the Indian plate on one side, Filipino plate on one side, Pacific plate. All these you have to talk about, that there is a significant oceanic convergence which gives rise to these particular kind of landforms. Okay, then let us take a look at this detailed question. Nowadays, such kind of detailed question is not asked anymore. But why are the world's fold mountain systems located along the margins of continents? Bring out the association between the global distribution of fold mountains and the earthquakes and volcanoes. Right. Now, in this, the world's fold mountain systems located across the margin of continents. Which mountain systems are we talking about here? Can you can you tell me about that? Which mountain systems are being talked about here? Himalaya is at the margin of which continent? Lala, very good. Molya, good. So you have Ural, you have Rocky, you have Andes, right? Appalachians, right? We can consider Appalachians as well. Atlas, Atlas is at the coastal area of Africa, northwestern part of Africa. So those examples you will take. Here, Himalayas won't suit the bill, okay, because they are not generally at the margin of the continents. And here, basically, you have to elaborate upon the fact that how they have been created. They basically have been created as a process of convergence. Oceanic. In the case of Ural and Caucasus, continental. Right? So, oceanic continental has created the Rockies, the Andes, Appalachians have been created when you had North America colliding with Europe long time back. So these are the events that you have to explain. Sierra Nevada, very good, Vedant. Now, in fact, uh, I will give you that as a mapping portion. The youngest fold mountains of the world, they are basically the Cascade Ranges, the coastal ranges that you find to the west of the Rocky Mountains as well. So they have been formed very recently, around 1 million years back. So that is one of the youngest fold mountains that get created. Then bring out the association between the global distribution of fold mountains and earthquakes and volcanoes. Here you have to talk about Himalayas also. So in the rough map, you have to talk about the various different mountains, the fold mountains, that is the Himalayas, the Atlas. It is along these Atlas and the extension of that you had the Moroccan earthquake which occurred, right? You have to talk about the Ural, you have to talk about the Rockies, Andes. You have to talk about the all these mountains and also elaborate that how convergences of various different types, they make these plate boundaries as sources or the regions of high seismic and volcanic events. That is what you have to explain in this. Okay, can you please mention the answer in this question slide? You want me to write the answer for this? See, in the first part, when we are talking about fold mountain, here you have to talk about the mountains which are situated at the margins of the continents. So, Rockies, Andes, then Appalachians, then Ural, right? Then, after that, here you also can talk about Atlas. Okay, all these mountain systems that you find, fold mountain systems, they are at the margins of the continent. So, here in the introduction, yes, Parshuram, absolutely feel free to do so. Niranjan, do we need to draw the map while writing answers or UPSC will give map? You will need to draw maps. UPSC doesn't provide you with anything in that case. So in the introduction, talk about that fold mountains get created. What are fold mountains? Okay, so talk about the fact that they are created due to the compression of the continental crust, which is generally a result of convergence either between the continents or between the ocean and the continents. So that ends up creating this kind of a fold mountain. They are spread and distributed across the world. Immediately after that, form the map, rough map of the world. Yes, Karan, perfect. Here you can also talk about cascade ranges. Okay, rough map of the world indicating the folds. Then after that, talk about the convergences leading to the fold. Then after that, here, what you can do is basically with a if you want, if you have enough time, very brief rough map again you can draw, or in the same map you can highlight the Himalayas, etc. And there you can talk about that these are the centers where convergences happen. Draw the schematic that we have seen in the case of the convergence. You talk about that how these become centers for earthquakes and volcanoes. Highlight the areas where the earthquakes and volcanoes happen. You talk about the various different types of convergences, leading to earthquakes and volcanoes. Here you have to take the example of Alps, you have to take the case of Himalayas also. Now you have to talk about that where you experience a certain kind of folding process happening, where you experience more probability of earthquake, circum-Pacific ring of fire, Mediterranean Asia belt, Mediterranean Himalayan belt, all that you basically have to focus upon, you have to be elaborating upon. Eventually, while you are trying to write the conclusion, in the conclusion, you have to talk about the fact that these areas are centers of very active geological activity, very active geological movements, due to which many of the events that we see, which impacts the larger humanity, is also resulted in. So we need to understand more about the crustal deformation and the continued geological activities in these particular areas in order to have a better clue and a better prediction of what is the actual scenario, something like that. So always in these cases, in the case of geomorphology answer, always better advised to talk about what you will do going ahead into the future. So always advisable to talk about that you need to carry out more studies about that, we need to investigate furthermore about these particular ranges. Okay. Ural Mountains is not between the plates. Ural Mountains is at the margin of the continent. So it was created long time back, before you had the creation of the Eurasian plate, when you had the combination, a continental collision between the portion which is Europe now and the portion which is the eastern part of the Asia now. That had created these Ural Mountains. Okay. Define mantle plume and explain its role in plate tectonics. That is something that I hope we can do. Mantle plume definition you can directly pick up from the PPT itself. That will form your introduction. Draw the image, indicate the image immediately after that. And its role in plate tectonics, that this mantle plume can give rise to convergence of the can give rise to the various different types of convection current which is initiated in the mantle, and that can push the plates apart and can direct the plates with respect to each other. Now, in the case of the mantle plumes, you have to talk about the fact that significant amount of residual heat keeps on getting released from the interior, both from the Gutenberg discontinuity as well as from the region of asthenosphere, and that generates excess heat where the solid portions they start melting, and that molten magma being lighter than the surrounding material, it tends to rise up. As it rises up, the its original place is filled by the solid substance of the mantle, which also melts and also starts rising up because of the excess heat provided. Now this can lead to filling up of the magma chamber, creating volcanic hotspots in many of the areas, but can also give rise to convection current in the larger portion of the mantle, and those convection currents which are generated will basically end up impacting the movement of the plates towards each other, away from each other, or in a transform manner. Okay. Should we draw mantle plume? Yes. In almost every answer for geography, almost every answer, an image is a must. Even if it is a rough image, an image is a must. It is required to be represented in all the various different answers of geography that you write. Okay. That is what brings about the representative characteristic in the answer. Discuss the geophysical characteristic of the circum-Pacific zone. This is also easy, where you have to talk about that circum-Pacific zone is a zone of convergences, right? Zone of convergence. Okay. So here also rough map around the region of Pacific is required. Then you have to talk about that how this zone of convergences, what type of convergence happens. So oceanic and oceanic continental convergence, both of them, they happen. You have to represent the schematic image of both of them. You have to talk about the formation of oceanic trenches and the landforms created, then earthquakes and volcanoes. Okay, these are the centers or the regions around which lot of volcanic eruption, lot of seismic activity is observed. So that is why these are the centers of the very active geophysical activity, and these are the general characteristics. All the landforms, ocean, from fold mountains in the Andes to the oceanic trenches, all of that you have to represent here. Okay, so that is required to be written in this answer. So here you need 2 to 3 images to be represented. First image will be the image around the Pacific, a very rough image where you indicate some portions of Australia, some portions of Japan, Philippines, etc. North America, you represent the coastline. South America, very random and rough image is required. Now, that is how you basically will represent around the region of the Pacific. And then another image will be of ocean-ocean convergence. Another image will be ocean-continent convergence. Is that understood? Okay. Do write the answers though. Please don't ignore writing these answers. Can we mention Ring of Fire? Absolutely yes. Absolutely yes. You have to mention that this is also what is referred to as the Pacific Ring of Fire. Now, after this, we come to the most important unit in the portion of geography, and that is climatology. Now, climatic characteristics of a region, they end up defining the characteristic of that region quite significantly. And when we talk about the climatic characteristics, that is the type of temperature experienced, the amount of rainfall that is experienced, all of that, that defines the climatic characteristics of any particular area. Now, when we say the climatic characteristics overall, here, from the food habits, the dietary habits, to the type of occupation which is followed, economic activity which is followed, all of these, they are dependent on the climatic aspect. So climatology is substantially conceptual, and climatology is very, very important for your portion of geography. In climatology, we will be studying about the atmosphere, about the wind movement, heating, cooling, rate of cooling that we have. We'll also be talking about the aspect of various events such as cloud formation, rainfall, thunder, lightning, cloudburst, hailstorm, cyclones, different types of cyclones which occur, and the events such as Indian Ocean dipole, events such as El Nino, La Nina, all of that we will be talking about in this case. Okay, all of that starts from the basic portion of atmosphere and temperature. This is the portion which is relevant both for your prelims and as well as mains examination. When we talk about the prelims, in the prelims, you will find questions associated with structure or layers of atmosphere, basics of heating and cooling, right? Questions associated with temperature inversion, isotherms, okay? These are the few of the questions that you will always find to be very important for your portion of the examination. Lapse rate, what is it? That is again something that you find to be relevant here. Okay, so these are the portions. Now, in the mains examination, questions are oftentimes asked from this. So, in the mains exam, you find questions associated with the basics of, again, layers of atmosphere. Okay, then you will find the portion of isotherms, and heating and cooling, urban heat island, then temperature inversion, the nature of it, the characteristic of it. So that is something that you will find here. So these are the areas relevant for your prelims and mains, and oftentimes questions are asked. Once you had a question about the evolution of atmosphere also asked from this area. That has also been asked from this particular area. Okay, so that is the requirement. Now here we start just like how we started the portion of geomorphology. We start with the very basics. In geomorphology, we try to understand the formation of planet Earth first, and that led us into the layers of planet Earth, structure of planet Earth, and furthermore, here we will try to understand the process of formation of the atmosphere around us, and then we will proceed ahead. But before that, when we talk about atmosphere, what do we mean by that? So, atmosphere is a thick envelope of gas that you observe surrounding the Earth's surface. Okay, it is a significantly thick layer of gas which surrounds the Earth's surface, which sticks around the Earth's surface. That is the atmosphere. It extends right from the surface for thousands of kilometers above the Earth's surface. It does extend. The atmosphere is held in its place by the Earth's gravity. Had the Earth's gravitational pull of attraction not been there, the atmospheric gases would not have been held in its own place. Right? So it is this atmosphere which allows the plants, the animal species, etc. They allow it respiration, and all those activities are allowed because of this particular atmosphere. Okay, now the air around us, we are not able to, we don't get to feel that air unless and until that air indicates a kind of a movement. We don't feel that air, we don't get that sensation that yes, we are surrounded by air. Whichever region you are sitting in, whichever room that you are sitting in, you will be surrounded by a lot of air, but you will rarely feel it unless and until you switch on a fan where you will observe the movement of air, right? So this atmosphere that we see, it has not always been what we see it today. Starting with the history of the planet, the history in terms of the evolution of the planet. Now, initially, the planet and the air around it was only consisting of hydrogen and helium. That was the only air which was present. Oxygen, etc., came pretty late, right? So you had the presence of hydrogen and helium, which was predominant. And then the atmosphere evolved into the later stages. So when we talk about the process of evolution of atmosphere, it can be categorized into various different stages. Initially, you had the primordial atmosphere when the planet was still a molten ball of mass. That was the primordial atmosphere. In this case, the atmosphere consisted of only lighter elements like hydrogen and helium. Now, these were very light. So, the solar winds, the solar activity, the solar flares, etc., they managed to erode this away very easily. They managed to shave it off quite easily. And lighter elements which were present, they were not present in very high density. So, over a period of time, these would be shaven off. Then we had the condition where we observed the evolution of new gases. And this happened in the phase what we refer to as the phase of degasification, Remember the phase of degasification that we talked during the evolution of planet Earth? When we talked about the phase of degasification, we basically talked about a situation where there were a lot of volcanic eruptions all around as gases from interior were released continuously. So this is when you had the phase of degasification. Okay. Now, here, at this point of time, when you had a lot of these volcanic eruptions, new gases were introduced into the system. New gases in the sense that you had gases like ammonia, NH3, SO2, CO2, H2O. All of these were basically released. All of these were released into the atmosphere. Ammonia, sulfur dioxide, carbon dioxide, water, all of these slowly and steadily were being released into the atmosphere. Now, ammonia or this NH3 that you see, that has been basically, that is the time when nitrogen was introduced in the atmosphere for the first time. Okay, so nitrogen basically was introduced into the atmosphere at this time. And nitrogen is not a very reactive gas. Nitrogen is largely in inert characteristic. So, while carbon dioxide, sulfur dioxide, oxygen, all of them could readily react with the rocky surfaces and could form various different types of compounds that you see. But then, when we talk about nitrogen, it has largely remained in the same proportion since that point of time. So, gases like nitrogen have largely remained in consistent proportion since that time. Why? Because nitrogen is not very reactive, whereas the other gases, they are very, very reactive. Carbon dioxide will easily and very readily react with the rocks to form different types of carbonates. Right? Oxygen, which is present, will readily react with the rocks to form oxides. Sulfates will be formed by sulfur dioxides, etc. But nitrogen is not very reactive. That is the reason why almost all the rocks that you see around us, those rocks are poor in nitrogen content. You won't find many nitrate compound amongst the rocks which are present. Why is that? Because all the various different types of rocks, they will not be able to react with the nitrogen. So nitrogen largely remains out of the surface. So once the rocks, they are devoid of nitrates, soil is formed. Why and how? By the weathering of the rocks. So if the rocks are poor in nitrogen content, you can think about it that the soil which will be created will also be poor in nitrogen, isn't it? Because soil is created by the weathering of the rocks. So if the rocks are poor in nitrogen content, the soil will also be poor in nitrogen content. And that is where you have the presence and the formation of all the soil across the world. They are poor in nitrogen. Most of the soil that you find in the world, that is devoid of nitrogen. That is why nitrogen based fertilizer, that is urea, is one of the most frequently used and the most prominently used fertilizer out there in the world, across the country as well. Okay, I will repeat the entire thing. Listen to this carefully. It has its connotation in the portion of biogeography as well. So when we talk about the nitrogen present in the air, nitrogen is absolutely non-reactive. It doesn't react readily, unlike carbon dioxide, unlike for example, sulfur, etc., nitrogen doesn't react readily. So the rocks which are there on the ground surface, they are unable to react readily with the nitrogen which is present. So as the rocks are unable to react with the nitrogen, what do you have? You have the lack of nitrates in the rocks. It is these rocks which will disintegrate, which will weather down to form soil particles. That is why majority of the soil that you see around us, that is also devoid or poor in nitrogen. That is the reason that the most significantly, frequently, and highly used fertilizer of the world is the nitrogen based fertilizer. Is that understood? I hope you don't forget it. By the time that we cover the portion of agriculture, I hope that you don't forget it. Okay, because this is the reason why across the country you will find that the demand for urea is very high. Right? The amount of subsidy provided to urea is also significant. Why? Because all the soils, they are devoid of nitrogen. And the plants, they do require nitrogen as a major nourishment, as a major component in that. Then we had the final phase, which was the modification of the atmosphere. This modification of atmosphere happened upon the evolution of the plants when larger plants came into existence. This happened after evolution of plants. So, when the plants came in larger portion, right, we are talking about the large plants. So when you had a lot of carbon dioxide into the atmosphere, which was created due to multiple volcanic eruptions and so on, that is when the evolution of large plants started happening almost 350 to 400 million years back. And when these large plants came into existence, that is when they carried out the process of photosynthesis. And when that photosynthesis was carried out in such large quantities, carbon dioxide would be consumed, oxygen would be provided. So, proportion of CO2 started reducing, and proportion of oxygen started rising. Okay, so that is something that you find in the case of how the atmosphere has evolved over the period of millions of years in multiple different stages. Okay, sir, why nitrogen had not been added? Where? Okay, see, nitrogen which is present in the atmosphere, it has largely remained consistent for a long period of time in the history of the planet. Whereas the amount of other gases, the proportion of other gases such as carbon dioxide, sulfur dioxide, oxygen, etc., the hydrogen, all the other gases, they have fluctuated. But nitrogen is largely consistent. And why is that? Is because nitrogen is mostly inert in terms of its chemical reactability. So the nitrogen which is present in the atmosphere, that is a consistent volume, which is able to maintain a consistent volume. Why? Because it is unable to react with the rock surfaces, with the ground surfaces. Whereas carbon dioxide, oxygen, etc., they react readily with the ground surfaces. Hence, the rocks, while they will have various oxides, carbonates, etc., they generally lack the presence of nitrates. Now, when the rocks lack the presence of nitrates, that means the weathering of the rocks basically will, which creates soil, that will also lack nitrogen. This is the reason why all the soil across the world, they are poor in nitrogen content. Okay? Yes, triple bond is present in nitro. I didn't want to get into that particular portion of chemistry because immediately the allegation is that you are catering only to the science students. So I don't want to get that kind of allegation. Gaurav, is that understood now? What we have been referring to with the case of nitrogen. You need a break? Okay. So how long a break do you need, guys? 15 minutes. But why? Can a 10 minutes break do? 10 minutes break will be fine, right? It will be the final break. The class will end at 8. So after this, one more hour will be there. So 10 minutes break will do. So let's give a 10 minutes. Let's have a 10 minutes break and we'll continue after that. Okay. A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm the same. Thank you. So now, once we have, so a question was framed in prelims, even from this area. And the question was that it was a kind of a statement based question which talked about the fact that oxygen has always been present in the atmosphere since the evolution of the atmosphere. Okay, so there you have to be aware that oxygen is one of the latest entrants into the atmosphere. And also understand, see, the evolution of species, that is something that you generally come across when we talk about science, etc. But the presence and the dominance of various gases, they have a significant role to play in the different types of species that you observe around you. For example, around 250 to 300 million years back, because you had so much amount of photosynthesis going on, oxygen which was produced suddenly started increasing in the atmosphere. The content of oxygen started increasing. The amount of oxygen in the water body also suddenly exploded in terms of volume. It was not as high, the atmospheric oxygen was not as high as it is today, but that sudden increase happened, and quite a substantial increase happened. It is during that phase when larger species started coming into existence, very large species such as dinosaurs. They started coming into existence when you had sudden surge in the oxygen level. When you had a sudden surge in the oxygen level in the oceanic areas, that is when very large species of organisms, they started coming into existence in the oceans also. It is a different matter altogether that almost all those species in the oceans, they got wiped out, and amongst them the smallest of them, that is what we refer to as the blue whale today, which forms the largest species on planet earth, that is blue whale. You won't believe that almost 200 million years back, blue whale was just one of the other smaller species in the oceans which was present, and oceans basically had many many larger species in existence. And that extinction happened around 94 million years back due to various geomorphic events such as continuous flood basalt eruption which happened across the globe, and that led to again the modification in the type of species which are present, and that brought about different kind of speciation into existence. So the species in the world, they also have a kind of a direct correlation with the atmospheric presence and the gases that you find to be present in the region of the atmosphere. Okay, now, after this, we come to the composition of the atmosphere. What is it that the atmosphere is exactly composed of? So, overall, the three major components of atmosphere can be considered to be gases, water vapor, as well as dust particle. Uh, Phase of degasification removes hydrogen and helium. No, before that itself, you had hydrogen and helium basically shaved off because these were so very light. These were shaved off at that point of time, around 4.5 and 4 billion years back. Solar system was not stable. So presently, we observe the solar winds and the solar flares. At that point of time, around 4 billion years, they were much more massive, much more intense. So it is said that those particular solar activities, and many of them, they shaved off that hydrogen and helium. Hydrogen was still present, and some amount of hydrogen was still produced at the time of the phase of degasification. Okay, Karan, is that understood? Right? Now, then after that, composition of the atmosphere. So these are the major constituents. So when we talk about all of them, so including the gases, water vapor, and the dust particles, each of them have a very unique and a specific role that they play. For example, when we talk about the gases, they are the providers of life, isn't it? They provide life and support on planet Earth. Now, when we talk about these particular gases, so here we talk about which gases? Nitrogen, carbon dioxide, all of these. These are the gases, oxygen, argon, these are the gases that we talk about. Now, other than providing them the kind of a life on planet Earth, had oxygen not been there, we would not have been there. Had carbon dioxide not been there, the plants would not have been in existence. So the gases, the first role that they play is basically provide life on Earth, right? So in a way, support life on Earth. Support life on Earth. And then they also help in carrying out the greenhouse effect. I hope we are aware that what greenhouse effect is, right? Everybody, I hope we are aware about greenhouse effect. Any one of us who is not aware about the greenhouse effect? So everyone is aware. Good. So they also play a significant role in carrying out, okay, partially aware. That is dangerous. That is very dangerous. So very briefly, I'll tell you what greenhouse effect is. So when we talk about greenhouse, what is that greenhouse? The concept and its derivation in itself comes from what was utilized in the higher latitude areas, because earlier in the higher latitude areas it would be very difficult to grow crops, because the nighttime temperature would fall to such a low amount that the crops would die of frost. So what was adopted as a methodology was basically a glass house was built, and glass houses used to be constructed. Now the purpose of these glass houses would be simple. They would allow the incoming solar rays to come in, right? They would allow the incoming solar rays to penetrate, and that would be trapped inside. That won't be allowed to escape. So that is what provided a prolonged heating. That allowed prolonged heating, and because it was a glass house which would be allowed for, which would be used for growing of the crops, hence it was named greenhouse. It works on a very simple principle, that when any object, or whenever you have in the form of the wavelength, so here when we talk about any object which is hotter will have a higher amount of energy. Object which is slightly and comparatively cooler, that will have lesser amount of energy, isn't it? Let us start writing these conclusions so that it is easier for you and you don't get confused later on. So hotter objects release higher amount of energy as compared to the colder objects, right? Now how is that energy emitted? Energy is emitted in the form of waves, right? Energy is emitted in the form of waves. Now, higher energy means that the waves are released with greater frequency. In very short time interval, multiple bouts of that energy is released. So the wavelength which is generated is very small. So when we talk about high energy waves, here, so basically they emit waves with a very short wavelength, because quite significantly and quite frequently they will be emitting a lot of these waves, so the wavelength will be very small, right? So these are also what are referred to as short wave radiation. So energy is released very fast. Hence, wavelength is small. This is what is short wave radiation. Short wave radiation. So short wave radiation has got very high energy level. High energy level. When we talk about the low energy waves, they are emitted slowly and steadily. So they will have very long wavelengths. So low energy waves, when we talk about the low energy waves, basically they are emitted slowly and steadily. These are your long wavelengths. So that is long waves. Now, here, what happens across the planet? So, when the sun shines, now sun is basically very hot, thousands of degrees Celsius. So the sun will emit lot of high energy, and that high energy travels towards the planet Earth in the form of a kind of a shortwave radiation. Right? Incoming shortwave solar radiation. Right? Incoming shortwave solar radiation. Now, this shortwave radiation, which is being received by the Earth's surface, it will end up heating the Earth's surface as well. When the sun shines throughout the day, the Earth's surface also gets heated in the process. Let's assume the Earth's surface is heated in such a way that it gains a temperature of maybe, or it exhibits a temperature of maybe around somewhere 40 degrees Celsius, 50 degrees Celsius at max. Right? Not more than that. Earth's surface rarely will indicate to you a temperature above 50 degrees Celsius. But that 50 degrees Celsius is still hot, but not as hot as the sun. So the Earth also, after becoming hotter, Earth also starts acting like a hot object. So it will also start emitting waves. But these waves will be of low energy level because Earth is comparatively cooler as compared to the sun. So the Earth will release the wavelength after getting heated, and that is in the form of long wave. What is also referred to as the long wave terrestrial radiation, because emitted from the Earth's surface after getting heated up. So this is what is also known as the long wave terrestrial radiation. Radiation. Okay. So that is a long wave terrestrial radiation released from the Earth's surface. Now that long wave terrestrial radiation, the energy level is low. Now, when the energy level is low, substantial portion of it will be trapped by the gases such as water vapor, carbon dioxide, nitrous oxide, etc. They will be able to trap substantial amount of it. Some amount of this will manage to still escape into the outside space. But a substantial amount of it will be trapped by the gases present. They will reheat the Earth's surface, right? And that is basically the greenhouse effect. Here also, in the basic purpose, the short wave solar radiation is allowed through the glass house, but then when it heats up the ground surface is nowhere equal to the temperature of the sun. So that is why it will emit a long wave radiation which will be trapped by the glass. Why? Because the long wave radiation has got lesser amount of energy. So, but why isn't it that the atmosphere is blocking the short wave radiation? Because short wave radiation has got very high amount of energy. So that is why short wave radiation is able to hit the Earth's surface. This is something that you also observe in, let's suppose, in the vehicles that you move in. Now, if you during the daytime, if you happen to close all the doors and the windows rolled up, you will find out that after some time, when you enter the car or the vehicle becomes much more hotter than what you left it, and it is much more hotter than the surrounding as well, which tells you that all the heat has been trapped in the interior, in the inside. So that is the principle of greenhouse effect. Okay, so here the long wave terrestrial radiation, okay, they have very low energy levels are trapped by the gases. Not all of that radiation, some amount of that radiation, some of that releases and escapes into the outer space, okay, are trapped by the gases, reheats the surface of planet Earth. This is your greenhouse effect. Now, is greenhouse effect good or bad? Apply your logic. What do you think? Is greenhouse effect good or bad under normal circumstances? Vedant, Ravi, Akash, Molya, Himadri, Akshay, Sakti, Aman, correct. Sarita, correct. Karan, correct. It is basically good. Right? Why? Because the greenhouse effect allows the planet to maintain its temperature during the night time. Otherwise, if you take a look at the planets where you don't have substantial amount of atmosphere, during night time, what happens is all that heat escapes. Right? So even in the case of moon, what do you observe? Daytime temperature is very high, nighttime temperature minus 200 degrees Celsius, minus 100 degrees Celsius. Why? There is nothing to trap the heat. Right? On the planet Earth, what do you observe? Daytime temperature, if it is 30, nighttime temperature would be 25 or 21. So temperature is maintained. Okay. So this allows the planet to maintain the temperature, allows the planet to maintain the temperature during night. Okay. By trapping the heat, it doesn't allow the heat to escape. Otherwise, what would have happened? The portion which is exposed to the sun, that would be hot, and the portion which is away from the sun, that would have lost all the heat, and it would have become very cold at night. So that is why this greenhouse effect, basically, by trapping these long wave terrestrial radiation, re-radiating it back to the surface and further reheating the planet, that basically allows the maintenance of temperature during the night. Is that understood? Kavana, how it allows, I hope that is understood now. Yes? Now, that is the greenhouse effect overall in simple terms. So the short wave solar radiation is allowed in, the long wave terrestrial radiation is trapped. So these gases, they also carry out out greenhouse effect, okay, and help maintain the temperature. At night. Then why is it that greenhouse effect is so much dished about? Why is it that everybody talks about that how greenhouse effect is leading to global warming? That is because when you have excessive amount of the gases such as carbon dioxide, nitrous oxide, methane, etc., now they don't allow any amount of heat to escape from the atmosphere. All that heat is trapped. So excess of anything is bad. So excessive heat getting trapped is leading to a rise in temperature across the planet. And ever since the time of the industrial revolution, the amount of gases, such as carbon compounds, etc., which have the greenhouse property, that release of those gases has increased quite tremendously. That is why around the atmosphere, the rate at which the greenhouse effect is happening, that has increased. The level of warming, that has increased quite significantly. Okay. Then we talk about the water vapor. Now, the atmospheric water vapor which is present, now that is responsible for all the various different majority of the climatic events that you see, from formation of clouds, thunderstorms, everything that is initiated, cyclonic disturbances, tornadoes, typhoons, all of them are initiated by the presence of water vapor into the atmosphere. So one might get into that misconception that you start thinking that okay, there is a lot of water vapor which is present. That is not the case. Water vapor is not present in very high quantity. Water vapor is actually present in very little amount. In fact, of all the water vapor which is present in the atmosphere, almost all of it is restricted to the lower portions. That is up till a height of 5 to 10 kilometers is where you have majority of the water vapor which is restricted. Right. Now, if you were to by some process, some artificial method, if you were to condense all the water vapor present in the atmosphere into liquid water, it would have covered the entirety of Earth's surface by a thickness of only 1 inch or even less. So that tells you that the presence of water vapor is not very high. But that wherever it is present, it can give rise to various different climatic events. So here, water vapor, right, basically has got two purposes. Gives rise to climatic events like rainfall, cyclones, etc. And secondly, water vapor also allows the warming to take place because water vapor is also a very potent greenhouse gas. So this also allows warming to take place. Okay, contributes to the warming process as it is a very potent greenhouse gas. Okay. And then comes the role of dust particles. Dust particles also end up playing multifarious roles. One of the roles that it plays is it traps the light from the sun and allows discharges and releases that light during the night time and allows us to see even during night. For example, in the darkest of the nights, when let's suppose there is no moon, there is no artificial light out there, still you have enough light where you will be able to figure out that okay, this is a tree, this is a road. At least that much amount of light is there, isn't it? Even under perfect darkness, there also you will have some light to figure out what is going on in front of you. At least you will be able to figure it out. Now, where do you get that light from? That is what is the diffused light, where basically when you have the dust particles which are present in the atmosphere, various dust particles which are present in the atmosphere. So as the light comes in, the solar light as it comes in, now it is scattered, right? And it is trapped within the dust particles. Now, eventually, these dust particles, they release that light during night time in what we refer to as the diffused light. Okay? So that is one of the major role played by the dust particles. So they scatter and trap solar radiation to be released as diffused light during the night, right? During the night time, which allows us to see in darkness. Then, I hope we are aware that for any condensation process to happen, you need a surface. A surface is required, a surface is a must. Only then will there be a process of condensation which will happen. So, when we talk about any kind of surface here, for example, so in that situation, so dust particles, they provide that surface for the condensation of water vapor. Water vapor condenses to form clouds. It is those clouds which will bring us rainfall or snowfall or any amount of precipitation. So those cloud formation, that is dependent on condensation. Condensation cannot happen into the air without any particle or any surface. So that surface is provided by the dust particles. So particles in general, they are categorized based upon their affinity towards water. You have certain particles which repel water, you have certain particles which attract water. Those particles which repel water, they are referred to as hydrophobic or hygrophobic. Those particles which attract water, which allow water, they are referred to as hygroscopic nuclei, right, which will allow water to accumulate around them. That is hygroscopic nuclei in general. Okay, so here when we talk about it, this forms hygroscopic nuclei or rather acts as a nuclei, that is, allows water vapor to condense on its surface, leading to formation of clouds. Okay, so this is basically the condition of the atmosphere, and basically the impact created by each one of them. Okay? And the various different components of the atmosphere. Now we come to the various modes of heating. Please explain it again, last point. Okay. See, understand, for condensation to happen, you do need a surface. Condensation will never happen into thin air. The clouds that you see up in the sky, what is that cloud made up of? Other than the good wishes and angels, what are the clouds made out of? They are basically the condensed form of water vapor. Condensed form of water vapor into ice, into liquid droplets, that is what composes the clouds. Now, that condensed form means that water vapor would have condensed there. But in thin air, water vapor cannot condense. Liquid droplet cannot be formed out into the thin air. So you require a surface. So you have various different types of surface. Few of them will repel water, few of them will attract water. The dust particles is the one which allows water to accumulate. So they will allow the water vapor to condense on them. So when the water vapor condenses, that is when it will form liquid water droplets or ice particles, and that is how cloud formation will happen. And that role is played by the dust particles. That is why sometimes when you hear about the terminology artificial rain, what is the process of artificial rain? In that, you basically bring about a situation where sometimes there is evaporation but no cloud formation. So in the atmosphere, in the upper air, you spray particles such as silver iodide, which allows or which provides a surface for that condensation to happen, which leads to the formation of artificial clouds and causes rainfall, right? So that purpose naturally is solved by the dust particles. Is that understood? Right? Or is there a doubt? Okay. Chinmay, in morning session, you were talking about foreign university geography book. Can you please say the name of the book or the universities? Please don't start buying those. I hope that you have better utility of your money. One of them is Stroller and Stroller. It is a very good book of geography. In case you are having a wish to study geography to a certain extent beyond what is required for general studies, you can always go for Stroller and Stroller. But the original book will cost you somewhere in the tune of 47,000 rupees, right? So, and the pirated versions of that, the black and white versions of that, which is available in the market for cheaper price, that doesn't solve the purpose, because black and white images, that all of them look the same. So that is one of the books, Stroller and Stroller. Then you have the Fundamentals of Physical Geography of Princeton. So that is also one of the good books. So you have multiple such books. Okay. Chinmay, I hope that is understood. Stroller is one of those books that if you are very much interested, you can always follow Stroller. Okay. Then after this, Karan, if there are already dust particles, then what is the need of silver iodide for artificial? Many of the times, those dust particles in the upper atmosphere, they get dissipated, or they are not enough in proportion to allow condensation to happen. That is why. And Gaurav, is dust helps to transfer water vapor from sea to rainier areas? Not always the case, no. Well, when we come to the portion of these rainfall, which happens, why it happens, we'll talk more about it. You will understand that it is not particularly associated. You have the sea spray, which is the one where sea spray releases those particular some amount of particles, which later on is carried by the air, and that forms the cloud particles as well. But then dust particles don't have much role in that. Now we come to the various different modes of heating. When we talk about the modes of heating, basically, we do know that heat from the sun, travels through vast space, vast presence of vacuum, right? Almost nothingness is there. And it traverses in the form of what we refer to as radiation. Radiation doesn't require a medium to travel. So the solar radiation that we receive on the Earth's surface, that is basically the first mode of heating that we receive. Now the air in between, that is not heated up quite sufficiently by the solar rays here. Okay, so when we talk about, let's suppose, air, and if I ask you a basic question, that let's suppose I have gas, again something you would have studied in your basic science, and if I have a solid, if I provide equivalent amount of radiation to both of them, if let's suppose this is a gas, this is a solid, I'm providing equivalent amount of radiation to both of them, which will get heated first, gas or solid? What do you think? Perfect. It will be solid. Why? Because the particles are attached with each other, very closely bound with each other, right? So heat is a form of energy. So that energy is transmitted very easily from one particle to another. Whereas in the gas, if let's say this particle receives some energy, this particle, due to that energy, will start moving here and there, right? So the other particle might not receive that much amount of energy. So gases, they are going to represent an inefficient mode of heating. But solid, they heat up quite significantly. Now, when we talk about the atmosphere, if suppose this is the surface, Eman, potent basically means something which is powerful. Okay, that is the meaning of potent. Now here, let's suppose this is the surface. And here, let's suppose you have the atmosphere. Now, the prime form of heating is that you have the solar insolation, or rather the solar radiation, which is received on the ground surface. Now that will heat the ground surface. So the ground surface gets heated up. Gets heated up due to solar insolation. Okay. Now, when the ground surface gets heated up, let's suppose near the ground surface, you have the presence of certain air particles, gaseous particles. The density of atmosphere is always going to be maximum closest to the ground surface. Can you think about the reason why? We have discussed about it already. But why is it that the density of the atmospheric particles, the gaseous particles, will be maximum near the ground surface? Sidhu, I think you are overthinking. Have simple thought. Yes, it is gravity. It is gravity which attracts everything closer to the surface. So because of gravitational pull of attraction, maximum density of the gaseous particles will be closest to the ground surface. So all these particles basically which are present closer to the ground surface. So as the ground surface heats up, particles in contact, the gaseous particles, they will also heat up by the process of conduction. Conduction is that medium or methodology of transfer of heat, where the heat transfer takes place because of significant because of being in contact with each other. That is why the heat transfer happens in that case. So when we talk about the region closer to the ground surface, so the gases, they will receive that heat, and those gases will indicate a process of heating. So that is why the gases, they indicate a process of heating, right? And these gases get heated because of conduction. Gain heat due to contact with ground surface. Due to the contact with the ground surface, they will get heated by the process of conduction. Okay, by the process, and due to the process of conduction, they will get heated up. Now, furthermore, when they get heated up, in the sense that when the gases get heated up, now, whenever a gas gets heated up, think about it. Heat is what? Heat is a form of energy, always. So that means the particles, they will gain higher amount of energy. Maybe many particles will even escape this system because they have higher energy. Now they will escape the system, they will move outside, gain independence of sorts. So what will happen to this parcel of gas, this section of gas that we have considered? It will become lighter because of higher amount of energy. It will become lighter, right? And it will then heat. It will, once it becomes lighter, it starts rising up. So that is when it will rise up and transmit the heat into the surrounding atmosphere by the process of convection. Remember convection current and convection that we observed, where we observed the simple experiment of a utensil where we had some water. Now, how did that water get heated up? Initially, you had formation of bubbles here, isn't it? Now, the base of the jar or the base of the container, that gained heat. Why? By the process of conduction. It was in touch with the fire itself. Now this, when it became, the lower portion became heated up, it gave rise to convection current, and that is how the entire liquid also heated up. So that is how initially it is radiation which heats up the ground surface. Once the ground surface heats up, then it will heat up the air in contact with the ground surface. This air parcel that you are seeing, which is in contact with the ground surface, that will also get heated up, right? Now, when it gets heated up, means it gains energy. And by gaining energy means it becomes lighter than the surrounding. And then it rises up and transmits heat in the form of convection. Okay? Transmits heat by the process of convection. So, lower portion of atmosphere in particular is heated from the ground surface rather than from the solar insolation. The lower portion of the atmosphere is heated directly from the earth surface. So the earth surface gets heated up and that transmits the heat into the air above. So I will write it down as well. Lower portion of atmosphere primarily gets heated due to heat gained by the ground surface. Okay, so that is basically how the atmosphere gets heated up in general. I hope that is understood. Okay, no doubt up till now. Okay, fair enough. So this is where we'll take a pause. We'll end the session here, and then the other portions. Okay, advection also we can complete. After advection, we will end it. So advection is another method by which heat gets transferred, by the way. What is advection? Advection is a horizontal movement of air. The wind movement that we experience, that is regarded as advection. Many of the times during the winter months, you would have observed that warm air comes in, and that warm air has got a kind of a cooling effect, right? Sometimes you would observe that it is a very hot summer condition and cool air comes in. It cools the region, right? So that is also a kind of a heat transfer. That is also a kind of transfer of heat. Hotter areas, they become cooler when you have cool wind coming over. Colder areas become warmer when you have warm wind. So this horizontal movement of wind across the planet, which takes place, which happens, that is significantly responsible for bringing about various different changes in temperature and distribution of temperature as well. So accordingly, it is classified into warm as well as cold advection. If the warm air comes in, it will warm up a region, warm advection. If a cold air comes in from some area, it will cool down the region, cold advection. So the transfer of heat through horizontal movement of air is called advection. It basically transfers heat from heat surplus areas around equator to the heat deficit areas across the higher latitude, right? So advection is much more responsible for the transfer and distribution of heat across various parts of the planet. So winds from the equatorial areas, or high temperature from the equatorial areas, they are, or lower latitudes, they are transmitted to the higher latitude, and vice versa. So it allows in distribution of temperature. So when we talk about cold advection, the process in which the wind blows from a region of cold air to a region of warmer air, which results in cooling of the warmer region. Whereas when we talk about warm advection, that is the process in which the wind blows from a region of warmer air to a region of cooler air. Okay, it warms up the region, warms up the region. Okay, that is the process of advection, and that is where we'll end the session here. And then I'll give you certain areas for mapping. I want you that uh, you should take any atlas that you have, any atlas available in the market, take it up, try to find out where these areas are, and don't be happy if you locate these areas, try to locate the surrounding regions as well. That is what will enrich your understanding. Will climatology finish next week? Probably yes. Otherwise, next after that, the Saturday is where we will finish it. Probably we'll be able to complete it. Let's see. So we talk about the map pointing. So first of all, I want you to locate some of the mountainous areas and the fold mountains. Cascade ranges. Meanwhile, any doubts that you have, feel free to ask. Cascade ranges, then Brooks Range, then Rockies, Appalachians. Look at the areas around as well. Sierra Madre Occidental and Oriental. Oriental. Then Andes. Then after that, Atlas. Then after that, Great Dividing Range. Then Caucasus. Then after that, locate Ural, Alps, Pyrenees, then Vosges. Okay. Then these are the few areas you can locate on the map. Zagros, then Kunlun, okay, few mountains, that is something you can take a look at it. Then after that, in the portion of the deserts, so Kavanagh gives suggestions how to keep in mind fold mountain erosion like drumlins, etc. Should we mug up? No. The eroded and depositional material landforms that are there, so that will happen slowly by with the help of identification of the images more and more that you see, that is when slowly you will be able to internalize it. So that if it should not be the case that I remember all of them by heart, but if someone asks me what is an esker, does that image come to my mind? So with the help of the images you should take a look into it. Okay, right? Yes, Ravi. Sierra de Mar or Sierra Madre, both of them. It is actually the Mexican word works for both ways. Then Sierra Nevada, Atacama, then Kalahari. Look at the countries where they are situated. Namib, Victorian Desert, Gobi Desert, okay? Then Dast e Lut, Robal Khali Desert, also you can take a look into it, right? So these are few of the desert areas. Then after that, locate Kola Peninsula, okay? Baltic Sea, Mariana Trench, Sunda Trench, Tonga Islands, Japan Trench, then Peru Chile Trench, okay? Reunion Islands, Sinai Peninsula, okay? And then Sea of Azov, okay? Look at the boundaries of Caspian and Black Sea. Finish this much portion and we meet again next Saturday where we continue. Lala, please help me draw various continental convergence, oceanic plate convergence across the world. Understand that diagram. About the plate boundary, are you talking about the plate boundary that it is about the various different plate boundary movement that we talked about in plate tectonics? So there, see, Nazca plate, etc. When you talk about, so there is an image. To take a look at the annotations of the PPT, there is an arrow attached there as well. Whichever portion you are unable to understand out of that, single it out, send a mail to me. Okay, we'll get that resolved. Don't worry. Then, Muskan, why the greenhouse effect is called green? Because, as I told you, it started with building of the glass house, and within that glass house, it was basically utilized for the growth of crops, and the that green vegetation was grown in that area, and hence it was called greenhouse. Okay, and why the color of the river varies depends upon the sedimentary load that is carried. I started preparing fully in July and was very sure about maths optional to take up, but for and joined coaching as well for that. But it's not going the way it should. What should I do? I even think of switching the subject, but not sure of what to choose. But then you have to understand that you have to basically single out why it is not working. If is it that the syllabus is much more? Is it something that you thought that you would cover something else by that point of time, or is it turning out to be much more difficult than what you thought? What is the issue in that? First of all, single it out. Otherwise, whichever other optional that you will switch over to, that will end up creating the same kind of an issue. Okay. So please understand, for any optional, you will be required to spend around 4 to 5 months on the minimum. Geography as an optional can be rewarding, provided that you internalize it, provided that you understand it. It has also got certain theoretical portions such as perspectives, which can be quite boring out there. Let me be very, very clear. I'm not going to sugarcoat the subject just because it is my subject. So take geography and your problems are solved in the life. No, it can be boring for you as well. So notification is where you find the details of the syllabus. Take a detailed look. Okay, which is the subject that you feel is doable, and if after coaching maths is still something which is not understandable or something which is turning out to be difficult, then you have to take a call. You have to take a call in the sense that take a look at the pyqs from the portions that you have studied. Is it something that you feel that you will be able to solve after reading for a certain extent, or is it something turning out to be very difficult? Then take a call. Okay, once you take a call, better to switch it at this point of time than to switch it at a later point of time. Always understand, for optional that you choose, interest is the most important, because it might happen that you won't succeed in the first or the second attempt, and you would have to read that subject on your own again, right? So you should have that much interest within you. You should have that fire within you. Secondly, material is available for that subject or not. In case required, guidance is available. These three should be. Generally, it will take 4 to 5 months for any optional. Join which is better for optional, anthro or socio. So if your writing skills are very good, socio. If your analytical skills are good, if you don't like to write too much, then anthro. Okay, those arrows and triangles, I mean to say, which is convergent and divergent, don't spend your energy on that, Lala. I would suggest to you, take a look at the diagram that we have put in that particular plate tectonics immediately after the slide where the plate tectonic theory is with the triangular data. We have talked about the plate tectonic theory. Immediately after that, we have given the plate boundaries. Take a look at those plate boundaries. It will there we have shown the arrows there. Don't entangle yourself in those triangles and semicircles. Okay. Okay, so that is where we'll end the session here today. We meet again next Saturday. Do these map pointings, revise the portions that we have completed. Till that point of time, do take care of yourself. Any issues which are unresolved, feel free to get in touch, write a mail. We'll get back to you. See you again next Saturday. Take care of yourself. Goodbye. Thank you.